With me today is Jorge Flores-Davila. He is located out there at Searle. Today we have a case study of irrigation at Fort Leonard Wood. We will show how irrigation affects overall water usage, and we'll include sprinkler types, water usage calculations, and ways to visually show the results of your calculations through the use of an Air Force developed spreadsheet tool. Jorge has a bachelor's degree in architectural engineering and will be receiving his master's in civil engineering with a focus on sustainable, resilient infrastructure systems this Sunday. Congratulations, Jorge. He is also a LEED Green Associate and currently pursuing becoming a LEED accredited professional. Jorge has been working with the Corps of Engineers at Searle for about 4 years now and has been aiding in the sustainability efforts at Fort Leonard Wood for about the past year. With that, I will switch it over to Jorge.
Thank you, Eric. I appreciate that. Again, welcome everybody. My name is Jorge Flores, and today we're going to go through a case study regarding the irrigation efforts and research done at the Fort Leonard Wood installation in Missouri. So just as a form of introduction, the Army Corps of Engineers, specifically the Engineering Research Development Center, the Construction Engineering Research Laboratory, Searle, has been working in conjunction with the Fort Leonard Wood Sustainability Group for the past 5 years on this sustainability initiative. Specifically in the FY 2013, the net zero water effort included identifying end uses for water, surveying water consuming equipment, and collecting data and information to ascertain how potable water is being used at that current installation. Certain policies that support that effort include Executive Order 13523, Executive Order 13514, as well as a few others. So the purpose of this specific study was to characterize and reduce the overall water use at Fort Leonard Wood. It was seen that a lot of water was being used. We'll look at some numbers here in just a moment that will show how some of this water was being attributed and how some of it was missing, or as they call it, their missing water. An average flow at the drinking water treatment plant that they have there in the installation is about 3.2 million gallons per day. Now, on average, the average flow of the wastewater treatment facility is 1.5 million gallons per day. So if you were to compare those two numbers, there is a difference of about 1.7 million gallons of water. And this was the issue because this was the amount of water that they were looking at as missing water. So it's kind of like when you think about what goes in must come out. And according to the numbers that they were providing us, what they were extracting from the river there that they have close by was not the amount of water that was going out. And so the purpose was to find out where is that missing water. So some of the spaces being considered for analysis, specifically in regards to the irrigation efforts, because they felt that maybe a lot of it's being lost through irrigation. So 4 specific areas were analyzed and used to see how much water is being used in those specific areas to then make a comparison of the total water usage for the installation. These 4 areas are on your screen: headquarters building, the parade field, the sports field, and the golf course. Now the golf course takes water directly from the river and it uses it to irrigate its water. So for total water usage, potable water usage, the golf course will not be included in the final calculations. However, we did include that in the analysis because when a total cost of water is done, those numbers will have to be included for that analysis when we're doing economic comparisons. So the different types of sprinkler heads that is very common in the field and also common on site are these 4 here. You have a spray head, which is typically done for landscape, very nice landscape irrigation for flowers, shrubs, and things right along buildings and walkways and things of that nature. You have rotor heads to cover large areas of turf grass. Also impact heads and rotator heads are the 4 different types. This will also be the ones used in the water efficiency calculator that we'll see here in just a moment. So the current water uses on site, the various sprinkler heads were used. We went out there and we started investigating some of the fields. This is specifically the parade field, the picture on your left. And the most common type of sprinkler unit that we found was the Rainbird 751 rotor series. So again, it's going back to the different sprinkler types. The rotor series is the most common used on site. So current water uses, in some places there's heavy overspray causing a lot of waste of water. In other places, in certain places, like on the picture on your right hand side, some of the sprinkler units are just old. They're old systems and they're not as efficient as the new systems that are coming out. So you can see on your left, this is a residential area where there's heavy overspray. There's a lot of water wasted. Most of the water being used for irrigation is really irrigating the sidewalk, which is obviously not the purpose of those sprinklers. And also manual irrigation is done on several places along the installation. And this was a little bit difficult to kind of calculate how much is being used, because it was more on a whim. Whether they pass a certain site, the grass might look dry, and they would go ahead and manually irrigate. And that was hard to kind of estimate how much water is being used, but it is causing some waste. So an important aspect of the study was taken from the headquarter building. The supervisor there was able to provide me data from the Rainbird computer, in which it gave a total number of 86,280 gallons of water per day, not including the manual irrigation done along the side for the shrubs along the building and things of that nature. So what was done was we acquired this number, and then we attributed our own method of calculating water usage to see how accurate our methods were, so that we have something to compare it to find out whether or not we can actually estimate the other areas that are not having a system as intuitive as the headquarter building currently has, that will give us a computer generated output. So the methodology used was the following. Using the 86,280 gallons of water for the headquarter building, we used that as the baseline, and the following equation there on the bottom was used to calculate the total gallons of water per day that was used for the specific sites that were mentioned. So just as to go through the nomenclature, the formula, so that we're all on the same page here, the ETO is the evapotranspiration. So it is the combined effect of water loss due to transpiration through plants and evaporation through the soil. The value used in this calculation was 0.282, and this is a verified number that we acquired from a study done by another colleague here, that he had published this number from the Fort Leonard Wood study that he had done. PF is the plant factor. The plant factor is different depending on the type of grass or the type of plants that are being used. 1.0 is the highest amount that is typically used, and that is mainly used for turf grass or lawns, which is most of the case. All of the irrigation that is done in the installation is irrigated considered as turf grass, which will allow us to make better recommendations here at the end. Everything for this particular study was done considering it as turf grass. And this was not for research purposes. This is actually what they reported to us, as this is how we irrigate our grass. We consider everything turf, and this is how we do it. And this is what we use in our numberings. SF is square footage of the total irrigated area. 0.62 is the conversion factor from inches to gallons of water. And then IE is the irrigation efficiency, specifically the sprinklers, depending on what sprinkler it was, whether it's rotary, whether it's the spray. The efficiency was included in there. So now that we know the nomenclature for all this stuff, we're going to plug in all the numbers that we have. The evapotranspiration 0.282 times the plant factor 1.0, the square footage. So this square footage that we have here is for the headquarter building. Again, these are all numbers that were provided to us by the supervisor for verification. The 0.62 unit conversion factor divided by the total efficiency of the sprinklers on site, which is recorded to be 75%. and that gives us a total of 85,057.32 gallons of water per day according to this methodology. And if we do a percent error as a comparison with the baseline that was given to us by the Rainbird computer, we find that the percent error is 1.42%. So with this percentage, we are fairly confident that we can give a decent estimate of the other areas that do not give a computer output, such as the headquarter facility. So what we did was we continued into our analysis, and in doing so, we found for the other areas we got all of the data necessary, the total area, the estimated gallons of water per day for each area using the formula, and then we calculated how much gallons per week was going to be used, and we learned that the irrigation taking place is usually done seasonal from the months of April through September, which total to be 183 days. And so using the data from the previous column, multiply that by the total amount of days in that seasonal area, and we get the water usage for each area during that season. So if you total up the area, the total amount of water being used according to our calculations is approximately 91 to 92,000 or million gallons of water for the season. Now, if you notice, the golf course is not included in that total number, again, because the numbers for each area is considered to be potable water, which is really the focus of the study. How much potable water is being used for the irrigation, and how can that be reduced? The golf course is using water directly from the river, and so it does not have a direct impact on potable water usage, but it will have an effect on the total cost of water due to the energy it requires for processing and pumping from the river and delivery. The water efficiency calculator. So now that we've gone through the methodology of how all of the sites were calculated, the spaces, the amount of water used, the total amount of water used seasonally, we wanted to verify those numbers with another method, and that was the water efficiency calculator. The water efficiency calculator was developed by Dr. Larry K. Isaacs. He works for the Air Force. This was specifically done for Air Force installations to calculate their water uses and to provide recommendations to help minimize potable water usage for areas that do not require high quality water, such as irrigation. This provides acceptable analysis for the DoD and water and cost analysis. And this is really important because when dealing with the government entities to use a tool that is acceptable by them and give them information through our research from a source that they are aware of and use readily, helps provide more credibility to the research being done. And so we're going to go through the worksheet here that was provided by Dr. Isaacs step by step. So this is how the page looks, the efficiency calculator looks. This is the front page. It is macro enabled. It is an Excel spreadsheet that will, if you're interested in using this in this calculator, you'll have to contact Dr. Larry Isaacs, and he'll be more than happy to assist you in whatever you need. Just recognize that it is macro enabled, so when you do save, it has to be saved with a .xslm format. So as we continue, everything here can be manually put in. There are certain things such as these drop-down arrows. Let's see here. The first drop-down arrow that you see, where it says select state or country, all of that is included. However, the baseline or the installation name, all of the ones that are currently in the calculator are for the Air Force installations. So Fort Leonard Wood is an Army installation. So Dr. Larry and we were going back and forth to add Fort Leonard Wood into the calculator, and in doing so, you have to get information such as the historical water data, precipitation rates, ETO values, and things of that nature. Once that's all generated, he can then populate it into the calculator, and so the calculator can work just as it was a normal installation. And that's something that again has to go through Larry to add it. A lot of these things, again, here can be changed, the amount of units, the kind of units you want, whether metrics or imperial, the type of unit for the area, whether square foot, acres, things of that nature can be changed there. Also, the water type. One thing that we're going to add here so that we can get a better analysis specifically for the golf course in our case is to add river water. You see here you have ditch, storm, recycled, potable water for analysis. And so what we selected was potable water for the analysis that we were doing for the areas that were shown. Down here at the bottom where it says water rates, this is an arbitrary number for the simple purpose of being able to provide what the results will look like at the end. What kind of results does the calculator provide? However, whatever the water rates that is used for your specific installation can definitely be included here with the units that is used for that rate, and then a simple cost analysis can be used through this calculator. Moving on to the third page, here's where you start getting a little bit more specific. You can enter either a total annual amount of water used, or you could enter monthly water usage depending on the kind of data that you have. For us, we have monthly data because they are seasonal. They don't have a yearly amount. And it also depends on how the weather is, and it's very arbitrary. So they preferred using monthly water data, and that's what we inputted. And again, the flow efficiency utilization number, that is the efficiency for the sprinkler, whatever the sprinkler unit that you're having. Ours was 75% for the rotor systems, the Eagle, the Rainbird Eagle sprinkler system. 75% was attributed to that, and so we included it in there. The following page shows starting to include what is the current landscape data, the current landscape usage, water usage. So just as a arbitrary, these are just, again, this is just an example so that you might see how it kind of works. The total amount of acreage on the top for the golf course in this case is 40 acres. The bottom here you title it out, and then at the bottom here on the right hand side, let's point here. Right here where it says native grass, right here you can select what kind of grass type you have there, whether it's warm season, cold season, native grass, or any other type of grass that you might have. You can select there, and that will obviously have an effect on the output that the calculator provides, which is very important to make sure you know what kind of grass your area is using. All of these numbers are manually inputted depending on the selections. And again, you'll also have to select what kind of sprinklers you have. And this will determine the efficiency and how much water is being used. The calculator does this all automatically. So once you finish all of that information, at the bottom of that very same page, you'll get these numbers here. These numbers we did not mess with. Spoke to Larry about it, and he said these are some numbers that are a little bit arbitrary. Because we could not get maximum flow for the current water usage, we did not input that. That's something that we're still trying to acquire. However, it did not seem to cause too much of an issue with the final results as far as how they are related to our findings. But that will help give various more accurate results here, but it is an optional point that Larry pointed out. So now once you finish with all of the current usage, it begins to populate proposed, and the proposed amount that the calculator has is dependent upon the inputs and recommendations that the calculator itself has already inside of it regarding drip irrigation and proper scheduling and things of that nature. It measures it according to the inputs that were placed in the previous screens. So again, we start seeing, for example here, we start seeing how the proposed water is being suggested through the calculator in comparison to the current annual water usage that was inputted before. So if we look down here, we see, okay, this is what we had put before for the golf course, native grass. And so they said, okay, well, if it's native grass, we're going to leave that just the same. And then water use factor, again, that's all dependent upon the type of grass that you might have. Impact heads, this is the sprinkler that you have. Now the efficiency factor depends on the kind of impact head. So this says, well, there's a better efficiency one, so let's use an impact head that has an efficiency rating of 38% instead of using 150% that was put in as your current usage. And that minimizes water almost 50%. This is the bottom of the same page showing the final numbers here. So it says total reduction is estimated to be approximately 55% for this particular example. And these are the kind of and this is the kind of thing that you might expect when using this calculator. Suggestions, recommendations, and notes are put on the right-hand side to help the thinking process when inputting and when considering different things. If you want to just, especially for the proposed stuff, if you want to compare, okay, well, what if I use this versus this? Or what if I use this sprinkler and this sprinkler? Or this sprinkler versus this sprinkler? The calculator is able to allow you to make those comparisons. So this page shows you what are some of the recommendation measures that the calculator is incorporating in its proposed recommendation. So then from 1 to 4, those are the ones that are really impacting the proposed water that is being suggested and the reduction amount. If you notice here where it says relative cost, for each recommendation, whether it's to install smart sensors or to install smart controls, it tells you about what effect will that economically have for you. So it says, according to the calculator, that smart controls have a significant in economic reduction versus rain sensors, for example. And the level of reduction for water usage is also high with smart controllers and things of the nature. So it gives you a description of what that technology is and how you can possibly implement it. And these other areas from 5 to 8, they don't affect the calculations, but they do have an effect on estimates, as the irrigated areas and plant types in number 8, depending on how those two factors are added or inputted as current measures earlier in the stages of the calculator, that will have an effect in the calculations, in the calculation estimates that we'll see here in a moment. Let me go over to the next page here. And so now we're getting to the point where we need to find the historic data. So if you want the calculator to input data that it currently has installed, then you select where that red arrow is showing use historic data. And the calculator, whatever the calculator has populated inside of itself, that is what you will use. Or if you have your own data, and let's say you weren't able to actually have the data inputted into the calculator, you can select the city, like that we did on page 1, the city and the state. You can select a close by, and if you have a weather station that's closer to your project site, then you can just say, well, I don't have all that data, but I have it. I don't have it inputted in here, but I have it on hand, and you can go ahead and use all of that data. You provide your evapotranspiration rates and your precipitation rates, and the calculator is able to consider both factors. Effective rainfall factor, and the percentage of rate where irrigation is required. This is again dependent upon your specific site. So for us, we considered, because they only irrigate between April and September, majorly, 100% for irrigation was considered then. And then depending on the weather, we kind of gave some allowance for early in the year in March, and sometimes later on in November, December, based on some recommendations, we gave some allowable 5% possibility for irrigation to continue later into the year. Those things again are you can manually change those things. And so this is the kind of results that you might be able to expect from the calculator. It'll give you irrigated area and water requirement by landscape. So depending on what you selected, so in this case we had selected the native grass for 40 acres, and it gives you the total amount of current water used, the proposed, and what is the difference or the reduction from proposed to current there. So again, if you wanted to compare, okay, well, what happens if I put mixed plantings, ground cover? What if I put trees in this particular area? All of that you can compare and say, okay, this will have this kind of effect. And then this graph down here will give you an outlook of, okay, depending for the area that you have with the different plants that you decide to have or you currently do have, this is what you can expect. This is the kind of results that you can expect. Over here on the right hand side, the monthly water use, this will show the total monthly water use current versus proposed that you for the project. So in our case, again, we gave some allowable 5% irrigation in March, so we had to make sure it started a little bit earlier, and then whoop, it goes up to April where 100% irrigation is taking place all the way to September, and then it starts reducing in October, and then 5% to 0 through December. And then you can see the comparison in the proposed amount as well, which is significantly less as before. Water use by landscape type, again, this is dependent upon all the information included up here for this graph. On the bottom part of the same graph is the water cost analysis. So if you remember on the very first page that of the calculator, we just put an arbitrary, I believe it was $2.65 per kilogallon. And again, that's an arbitrary amount. You can put whatever the rating is for your project, and then a very similar type of analysis the calculator will provide depending on those inputs. So if you compare a comparative analysis, this was a comparative analysis done with our measures, the methodology that we used. And so we look at what the calculator just provided, and then we make a graph with our own calculations, and we see something very similar. Now this is plotting all of the areas that we included, including the residential area. And we see something very similar being provided here. Current monthly used versus proposed, and then when we compare total water usage for the installation, we find a significant difference in the total amount of current water used versus simple things that you can use to minimize water usage and how that will look over the span of a year, and this is what it'll look like. So what are those recommendations? So the first recommendation we have is to zone areas. Maximize water usage by zoning areas. For this for a Fort Leonard Wood installation, only one area actually zoned their space, and that was the parade field. Other areas, they were just irrigated as they saw fit, depending on how the land looked. They put the sprinklers as they saw fit. So there wasn't any zoning per se in those other areas, and that can cause a lot of overspray, not only on sidewalks, but there are some plants, for example, that require more water. If you remember the plant factor from the equation, the plant factor determines or helps the installer know how much water a certain zone is going to require, because maybe a tree requires, well, trees require more water than turf grass, but shrubs, and then shrubs require a different amount as well. So if you zone it in such a way where the water can be attributed depending on how much water is required by the grass, the trees, and the shrubs, you can definitely maximize water usage for those areas, thus minimizing the total amount of wasted water for the very same spots. Also scheduling. We mentioned how sometimes we found that the water scheduling was not done on a consistent, routinely basis, and that will cause some problems, because sometimes as one might pass by, might see, oh, the grass is really dry. Let's turn on the irrigation. Let's turn on the system, and so they'll turn on the system. But what that does is it takes off the routine, and it causes a lot of inconsistencies in the watering. And sometimes the water the grass doesn't need it, but yet it's breaking the scheduling. So recommendations, literature advises from like 6 p.m. to 6 a.m. watering, and then with the water sensors, the rain sensors that the calculator was suggesting, for example, you can minimize the amount of watering. If it's raining, you don't have to irrigate. Water sensors help adjust that, and that's important to include in your scheduling, because when we were on site, it was noticed that at some times when it was raining, the irrigation systems were also running, and definitely that is an easy measure to minimize water usage. Another one is to effective sprinkler placement and adjustment. Sometimes some sprinklers, they're either placed too high, or they're placed too low, or they're placed all over to an angle too much, where when it kicks back, especially for the impact heads, as they continue to move over, that extra water moves over more to the sidewalk than it actually stays on the grass. And if it's put at an angle too high, some of it has the opportunity to evaporate before it even hits the grass, and that's wasted water as well. So a professional installer should definitely be consulted so that the maximum amount of water that is being pushed through the system can be used for the area being irrigated. Time of day irrigation is also very important. If irrigating during the hottest part of the day, that also allows the opportunity for most of the water to be evaporated before it hits the grass, or if it's during the windiest part of the day, when it's spraying, a lot of that water will move as a result of the wind to areas that is not intended for irrigation, like sidewalks or streets and things or building sides of buildings and things of that nature. So those are very simple things that can be done to help minimize wasted water. When possible, incorporate drip irrigation. Drip irrigation is a very, very neat method of micro irrigation, but it's best used for things like the landscape, the aesthetics of a building. Drip irrigation has a 90% water efficiency versus sprinklers that have anywhere between 30 to 75% efficiency. The ones that we used, the Eagle Rainbird systems, they use 75%. So this could really help minimize the amount of water, and it's controllable. That way you can irrigate as the certain plant type requires, and that's a very neat and very good tool. When it's possible to use, definitely worth the consideration to do so. So in conclusion, at Fort Leonard Wood, sustainable methodologies are currently being explored to be adopted by the personnel there at Fort Leonard Wood, so that they might help minimize the wasted water, potable water that is currently missing. And seeing the amount of water being used on a daily basis was alarming, especially in the residential area with all the overspray that was taking place. The misapplication of some of the sprinklers there is definitely under investigation now, so that they can help minimize and address the issue of the missing water. Recommendations for minimizing water usage impact are being considered. A lot of the stuff that we have found and those are really simple measures, a lot of that stuff they are considering so that they might improve their water usage and finally find out exactly what's going on, whether a lot of water is being lost through leakage, or is a lot of it being lost through irrigation. So with that, I'll open everybody for questions if anybody has in regards to our study. Thank you again for attending.
This is Eric again. I've opened up the Q&A block on the far right-hand side of the screen, and I'll go over a couple of things as well. Basically, if you want to ask a question, type your question in the data entry box in the very bottom right. It'll show up on my screen, and then I'll read it for the sake of the recording for Jorge to answer. Also, if you want a copy of the presentation, there's a PDF for download in the file share block in the almost fully right bottom, and also there's some web links in the block above that. One is to the Sustainability and Energy website. That's on the MSRI system, and that does require a login, but it's a free registration. We also have a link to our past webinar videos if you missed something in the past. And if you can't hear me saying this, there's a link to the troubleshooting page. But I guess if you can see and hear that, then you're obviously in. So I'll see if any questions come in. Also, in the meantime, there are CEUs available for this. I'll show the contact information when we're done with the Q&A. And basically, they're in groups of 5. And once you answer 5 quizzes and send the results to Lindsay Pruitt, whose email address is up here on the top part text box, then you can get the credit. So we have a question from John Anderson. How does drip irrigation work for turf grass?
Drip irrigation is not typically wanted for turf grass because mainly drip irrigation targets the roots for things like trees, especially, and shrubs. So when people use drip irrigation, it's hard because for that to happen, you need to have long tubes and things of that nature. And some areas, especially in this site, the areas are so large that to have these tubes to put underground and or wherever, however some people do it, it does not work as well depending on the space. Again, the efficiency and how it is used for turf could still be fine for the simple purposes of what irrigation is used for, but it's not recommended for turf grass in large areas due to its primary usage. It's a good question.
Okay, thank you very much. I typed a little synopsis of that in the response as well. So looking for more questions if anybody has any additional questions. Jorge, do you want to bring up the next slide with the contact information?
Sure. If you have any questions that perhaps you might not have been able to address, you can contact me. My contact information is there first. The PI for this particular study is Annette Stumpf. Her information and phone number is also there. And if you're interested in acquiring or kind of knowing a little bit more in regards to the water efficiency calculator, and you might want to use it for your project or any study that you might have, you can contact Larry K. Isaacs. There, his email information, and if you want, you can include me in the email just so that he knows that it was via this webinar that that you found that information that you were interested in.
Okay. Well, I don't see any more questions coming in. So, Jorge, thank you for joining us today and for giving us this information and this valuable contact info. That spreadsheet tool looks like a very cool thing to have for a tool in the toolbox. And I thank everybody for attending and hope that all of you found it useful. I'm going to stop the recording now, and this will be uploaded onto the Sustainability and Energy website videos. If your colleagues are interested and they missed it, probably give us about a week to process it, and then it'll be there. Thank you very much. This is, again, Eric Mucklow at headquarters. I'm the only Mucklow in the global email database if you're looking for me. So have a nice day.